So at the next part, we will really show this integration of AI models into XR projects. And here we basically have three different parts. The first one is the PCA, the Passthrough Camera API from Meta. That's basically the most important part because most of the things people do with AI are really dependent on the camera image. So we want to show you that first. And after that, we watched into these two opportunities. One time we hosted APIs, which is really easy to set up because we use the online providers API. Here we used NVIDIA's NIM service. And the third option is the local inference, where we run the model on our laptop or your PC at home. And we will call the model, which is running locally from our MetaQuest, to have a really fast tracking of objects. And it's using Roboflow. Yeah, I will show you what that means. So let's get into the Passthrough Camera API first. So what is the Passthrough Camera API? Basically, what you can do here, just what you see here is one project I built using the Passthrough Camera API. You can get the camera image and you can run different operations on them. This one here, for example, is run directly on device. It's using OpenCV. And basically what it does, it's getting this really intensive colors of the orange ball. It's just searching for the colors in the picture and gets the 3D position of the ball with that. And with that, we can have really this mixed reality moment we already described in the first part, which we saw at Lucas projects, because we have interaction between real world and virtual objects. So yeah, how to get this, what can you build with PCA else? First, you can combine AI and computer vision. Here's one of the projects we'll share with you today. It's the Meta PCA Roboflow project, which is using this tracking of custom objects, and based on how far the beers are away from each other here, you can see they're either sad or happy. You can also use it for really more artistic ways, I would say, like visual effects or shaders. You can see here the camera pictures used to blur the real environment or even zooming. And you can just get creative with shaders based on the camera picture. You can understand your environment, spatial understanding. You can map objects around you, and based on that, you can maybe then ask questions or automatically place content or things like that. And another project or application which I find quite interesting is this remote sharing option here, because you can basically share the view you have with other people. Here it is used for the here it's used for an application where you share your actual camera view with an assistant, which is maybe remote, and he can help you in different tasks. So how can you access the PCA, and what is it about the performance of the PCA? So actually there's two different ways. Either you can use the native Android applications, which is actually using the spatial SDK of Meta, or the alternative would be Unity, using the Unity webcam texture. I'll tell more about that later. But that's the basic way to do that. There's example projects for both. It's really easy to build. Android is, or the native Android spatial SDK is quite nice to have fast build times. You can build the application in seconds, because that's also actually a limitation you always need to think about. You can't use MetaQuest, Meta Horizon Link, like I was showing you in the development for XR before. no, you always need to build an APK to send it directly to the device. And that can take some time, building this with Unity. So if you want to have faster build times, you can maybe use the spatial SDK. But on the other side, it's quite more, it can be quite more complex first to find into it. And if you really want to build fast and iterate fast, putting in really complex physics like that, then probably Unity is your first choice. And about the performance, so it's the tool is using the Android Camera 2 API. So it's built on top of that Android API, which is already existing. It's using the left and right RGB cameras, which you can see here on the MetaQuest. And it has a limit or maximal resolution right now of 1280 times 960 pixel at 30 hertz, which means also with a latency of 40 to 60 milliseconds, you can just get around maybe like a 30 pictures per second. So even if your application would be really performant and really fast, and you can run a lot of analysis on the pictures, like it would be maybe possible like 6 times per second, you're still limited to this 30 pictures per second. So that's something you maybe need to keep in mind to work efficiently with it. Also, take care, using Camera API can be quite performance, need a lot of performance. So you should take care of finding a balance between using camera and maybe your rendering for your application. And maybe you should use this MetaQuest Developer Hub I already showed you, where you can use this metrics to analyze like how performant your application is, so that it doesn't have bad effects on the user experience itself. So what I said before here is Unity is using for Unity, you can use the Unity webcam picture. But actually just last week, Meta announced a new Passthrough Camera Access API, which we already tested for you and directly integrated into our projects, which we show today. And this Passthrough Camera API Access has a lot of advantages. It's really easy to integrate, to build with it. If you already built another project with the old Camera API, that's no problem, because you can, in less than 1 hour, probably even a half hour, dependent on how often you used it, let's say, you can migrate your old project to the new one. It's support using timestamps. So for each camera picture you get, you also get like the exact time point when it was done, so that you, based on that, have some more information available. That was not possible before. And what's also not possible with the old Unity webcam texture was that you can now access both camera pictures of the left and right side at the same time. And that's also something we tried out, and which is quite interesting. And I guess there's a lot of opportunities to maybe even build completely new use cases with that, maybe during the Meta competition this month. And yeah, about the implementation, I will not go into Unity now, because it was really simple to change it. So basically, first you need to update to Meta Mixed Reality Utility Kit version 81. And anyway, and you need to give the same permissions than before. You just, in this case, just need the headset camera permission. And the entire setup of it is just 3 lines. You don't need to download any external project from GitHub like before. It's just this 3 lines to set up the camera. It's already integrated in MAUK version 81. And after that, you have the camera picture already available. You can directly get the camera access or the texture access. they say in the first few frames, this texture you get here can be still black because it's still initializing, but you really don't need to take care of anything. There's the texture, and from that you can directly get started. And yeah, it's really, really simple. And I'm really surprised and happy. So how do you access both cameras? That was actually a bit more tricky for me because I tried to set it up by the code itself with the first part here, adding just changing the camera position type to left and right. It was not possible for me now in the code. But what I was doing is I was creating two game objects, and I was adding this new Passthrough Camera Access component, which you can see in the screenshot here on the left, to a game object called left and right. And I just put the camera position here in this field. I changed it to left and right and just added it here as a dependency from the scene. And when it's already set up, I'm just able to get the texture from both and add it to a image view in my GUI. And how it works, you can see here. You have now both different cameras. Like you can see, the left camera is seeing a bit different picture than the right camera. And now it's even more clear. You can see the panda not at all on the left camera, but on the right camera, and vice versa. And yeah, you get much more data. Still 80% of the cameras overlapping, but that's also advantage. You can get this overlapping data and do something with that. You have 20% additional data on both sides. Just have also attention on that the cameras are actually crossing each other. So the left camera actually sees more of the right side, and the right camera sees actually more on the left side. That can maybe be important if you both of us. But you can definitely use it for your advantage, and I'm looking forward to see some nice use cases with that. So that's about the Passthrough Camera API. Like I said, we already integrated into some of our AI kits, which we will start to talk about now. So the first part will be about hosted APIs. So APIs which are somewhere on the server. We don't need to take care of the AI ourselves. We just have communication with it. And yeah, we just send information and receive information back. And with that, we can work. Like you can see, it has some advantages and disadvantages. Like I said, it's really easy to implement. You are not limited by your local available CPU or GPU. You basically have unlimited model sizes because these models can usually on the cloud server be quite big. And you don't have any of the other problems you usually have if you need to run it yourself. The cons could be it's dependent on internet connection. If you don't have also on the how fast your internet is, for example. These APIs usually are paid, and you also can't customize it, or maybe you don't want to send your data because you want to have it private. But let's see what we can build with that. This is just the example of how to use this APIs with Unity. So basically what you do is you build a Unity web request and you send it to the server. What you get back then is successful answer, and you can here print it. I don't go too much into detail here, but you can see what it looks like from the project of Lukas Martinez here. So basically, at this moment here before, we was taking a picture, which is sent now and processed in the server, which is just available by the internet. And we get information back for all the objects. It's zero shot detection, so it just gets all the objects it recognizes. Let's say it's not for custom objects, but it gives really a lot of different objects he can recognize from the picture back. And then this information was converted into the 2D position on the camera image we just saw already. And then we get the 3D position, how far the objects are away from you using also Meta's SDK. And yeah, that's what we basically offer to you. You can see it here again for a different case. You can see a lot of the fruits are detected here, other objects. And that's the general approach. Like, you don't need to train your own model. You just get really general data, like about everything the zero shot model can recognize in your room. And yeah, this AI kit is available from the Sense AI Academy and is here available by the QR code. Exactly. There's another view of it. It's using Dev API, Meta's PCA, and the Florence 2 object detection. Yeah. And what I maybe need to add, right now we are still also in the process to convert this project to the new Passthrough Camera API. It's still in process. And right now, the Florence model, you will maybe notice on NVIDIA NIM service is right now not available. So if you have any problem with that, we are already in investigation of that. We will drop you the information in the next days about it. But yeah, all the code for that is still available for free on GitHub, and feel free to check it out. We will, yeah, not dive into the project right now here, but just because we have so much more to show you. So the alternative to this hosted APIs, which is somewhere in the internet, is the local inference, like we already said, which runs the models directly on your local computer and makes it then over the local Wi-Fi available to your MetaQuest, for example, and you can track nearly in real time with that. So the service we use for that is Roboflow. And what is Roboflow? Roboflow is, I have it here, the world's largest collection of open source computer vision data sets and APIs. So what does Roboflow offer? There's more than 250,000 fine-tuned models, which are really fine-tuned on specific use cases, just tracking like a specific object, like just bananas or just apples or anything else. We had it for Rubik's cubes, for example. So there's so much models. They also offer like more than 1 million data sets with images, or 500 million images of all that. So it's a really, really cool, big and important tool to have. You can build so fast your own applications with that, and with our AI kits even faster. But that's what we will show you now. So I just have a video also additional here. You can see here it's tracking the motion of humans. Yeah, exactly, the car motion out of the perspective from top. It's counting objects you can use it for, and yeah, everything in real time. You can run it locally really fast. And yeah, you can also build and train your own models to track your custom objects. I always have this this figures, for example, for that I made a lot of pictures actually and trained my own model. But you can also make pictures of any object of your interest and just train the model yourself. Exactly. And the best part is they also offer 33 credits per month. So you can really build a lot for freeware and use the API for free. 30 credits, I need to say, is really a lot. I built a lot of models in per month, and also train them, which just cost less than the credits. So yeah, it's nice to use. What can I use this Roboflow for? It's basically key point detection, which means you detect specific points of a body, for example, like tracking the hands or the entire positioning of the body. You can detect objects, like for example the figures here, or like you was able to see here the skater or the swan here. You can do segmentation. Also, like you can see here for the skater, this one. He is really getting the entire outline of the object. It has multimodal capabilities. You can put images and text in there, for example, questions, and ask questions about the text. And also classical classification, like just labeling image to one or two classes or multiple classes, just for a topic, for example. And what is the pipeline? What do we need to do? So the first part is the collection of data. So we collect data, for example, from the camera, doing a lot of pictures of the object of our interest. Then the next point would be data annotation. So we have a lot of pictures, and then we say for each picture, at this position is the object I want to track, and we just put a square around it, and that we can use after that for the training of the model, which is basically 90% automatically at Roboflow. It's automatically training, and you just need to wait a couple of minutes. Actually, per model, maybe it could be 15 or a bit more time, depending on the size of your data. And at the end, you are directly able to call the model by already automatically provided APIs from Roboflow. So what tips I can give at the data collection? Try to use really a lot of images. 50 images of one object, for example, is not enough. You need to have really images in different environments, different lighting of the object, different distance to the object, or different angle. And also here, for example, I use this two figures, the panda beer and the normal beer. And also try to have a balance of both objects. Like sometimes do pictures with all of objects inside, sometimes do just of the panda beer, one of the normal beer, and have the same amount of them. Not like you have 100 pictures of the panda and just one object, one picture of the beer. Then probably your outcome will be really tailored to the panda beer itself and not to the different objects you actually wanted to train it for. So how do we know when we have enough pictures of what we want to train our model for? So for example, the accuracy, so how good our model is seeing the things, it stops improving at some time, but also that part is taken care of by Roboflow. You will see that the model is really good performing in different conditions. For example, if you have a bit dark lighting or you're outside and inside, does the model perform in both environments good, or just inside because you just trained the model with inside pictures? And also, if you add more and more pictures, maybe at some point the result doesn't change and doesn't make the model better anymore. Then every picture you just put on top of that will be just too much data and will not have any benefits. So how do we annotate data in Roboflow? It's actually quite simple. I just put it here in the video. There's, for example, the classification. where you just classify the entire picture into different classes. This one is object detection. For example, now you put just boxes around the different objects and give them a class, panda or beer. Then at the segmentation, you need to make the entire outline of the object, but Roboflow also have tools to help you to make it automated, like you see. And for the key point detection, for example, where's the leg, where's the arm, you just have this tool where you can pull the points to the correct position of it. And also for this multimodal, you have your picture and you can ask questions about and can also append the answers for it to train the model to answer questions about pictures. So how do we train the model? Basically, what we do is we split our data set. We have like a lot of images. We use maybe 70% of the images for training itself and maybe 30% for testing purposes. Because if you use 100% of the data set just for training, then the data set will probably be training just on your just to recognize these events of your training data, and will not be applicable to images which is not in your training data. So that's why you probably need to split your data set in the training part of this data and test part of your data. There's pre-processing of images, like adding grayscale to it, adding augmentation like rotation, scaling the images to different sizes, just to put some, let's say uncommon patterns into it, so that the AI has some harder time to track the objects, because if it has harder time to track these objects in training, probably it's working better in real world examples, for example. And yeah, that's about it. I will better show that in some seconds shortly in the real environment. And what you need to do just at the end is calling the model, which just got automatically trained by Roboflow by using hosted APIs or the local inference, which is in our test 40 to 50 times faster than the hosted API. There's also some new APIs available here, but still the local inference is like 10 times faster. And yeah, what do you need to call it locally? To call it locally, I will show also the project to you. You need Python. You need NVIDIA CUDA, which allows your models to be deployed to your graphic card, GPU. And you need to have a container environment. It's called Docker, where you can put these models inside and let it run. But I will show you that in some seconds. And and Unity, take care that you have internet access allowed, and that it is allowed to use this unsafe protocol HTTP, so that you can test it locally. Before I jump into it, but I guess that's it, right? Yes. There's this AI kit which we created to make it really easy to use. It's basically just using 4 lines of code, where you first create a Roboflow inference client with your API key you get from the Roboflow. Then you can put your image, which you get from the camera, into this inference request image. And then, depending on what you want to do, if you want to do object detection or if you want to do segmentation, you create a request like this, object detection inference request or segmentation request. And you also just put the created image in here, and you put here the name of the model you want to call based on the Roboflow naming. And you just call it and get it easy here back for working on it. And here's the GitHub link for our AI kit. And yeah, I will show you what it probably looks like. So first we could see here the Unity integration we built for it. You can do all the operations in Unity here directly in the editor, but you can also use this on the MetaQuest, where you can see here that we are tracking with objects in real time and give some feedback about it by showing some animations. Other use cases, for example, here by one of the other Sensei mentors built by Rick, is a ball application where it's tracking the balls. It was really easy to build with our toolkit. And another use case I found at the Sense AI community. And he's basically using the application to get segmentation of, for example, clothes. And then he's using the MetaQuest controller to, make shows a bit more fun. Exactly. And that's the theoretical part about the AI kit we provide. I show you that's the kit we provide on GitHub. Here's how it's easy to integrate after you downloaded this. And also I wanted to show shortly the Roboflow website itself. You can easily create an account here. You can create new projects, which you can create for object detection or anything else. For example, for object detection, you just give it a name. You say what you want to annotate and you create it. I already did this here for the beer example I was mentioning. Then what you would need to do is uploading images. You click the buttons, you upload images into it. And after that, you can annotate them. Also, that step is already done here. But like you can see, if I would annotate pictures, what I have here is this annotation tool they offer. It's not for object detection between this beer and the panda. And if I, for example, now go through pictures and I see like, oh, here's another object, for example, I just create a bounding box around there. And I would say what type of object it is and can save it in theory. And that's how I can annotate all the different pictures here. And if I'm done with that, I can just train my own model, just clicking on a button here and adding some options here and just press a button train. And what will happen then is we train a model and I hear this, we train a model, for example, this model, we get like how accurate it was, and we can even directly test it here by also uploading a file, for example. Here's already an example image that was successful. He thinks there's a 88% chance that this is a panda and 90% chance to get the beer. And that's actually the output which he creates. Like you see here, beer and panda, which we can also call via our API or locally. There's some additional information about how good the model was trained. And yeah, then I'll show you shortly how it would work in Unity. So I have here the MetaPCA Roboflow project. I'll just open it. And while doing that, I will show you how to set this local server. So actually, Roboflow is offering this website or this project, which is called Roboflow Inference. And they also give instruction of how to set it up. So you need to install Docker, which I already did here. It's just an easy application, let's say, where you can run the model inside so-called containers. And additionally, you need to install this NVIDIA container toolkit, which gives you the opportunity to run the AI model faster by using the graphic card available. You can just do it on a computer where you also have NVIDIA graphic cards, mostly Windows or Linux computers. And what you then need to do is install a Python environment. I don't know if I already added it here, but it should be Python 3.12, which I did in here. So I created an extra project. I installed Conda, which is for Python to have a virtual environment where I can always create new environments to um, take care of the dependencies. So here already you can see there's a Conda folder. I activated Conda. I'm in this environment now. I can also ask which Python version is installed. It's 3.12. And what I now need to do is starting an inference server, which is also what you can find here, inference server. This package I already installed before in this Conda environment. So what I just need to do now is starting a server. And that's what I will do now. I hope it doesn't take too much time. And the theory there should be a server started here. So he's getting a new image. Okay, it looks like he's pulling it new. It will take some time. Anyway, I prepared for it already. So usually he will get one of the images here for Roboflow, which is running the local server. I already did that. It's in here, local server. So I can also start this container manually. And it should be starting now, and it's running. You can also see there's a container running for it. And that's the basic part. Now there should be this Roboflow inference server running locally. I can check that by using an extra application for that. It's called Insomnia. With that, you can test web APIs, also REST API. They're mostly REST APIs, which is just web servers which communicate with some standard, in this case with JSON files. And I created some example calls here, which is calling the local host, which is my local computer. And he is using this port, which is you can find here. It's a standard for this Roboflow. It's port 9001. And I can just ask now, okay, which models do you have registered? And he answered back in 70 milliseconds, or I don't have any model installed. So for our example, we wanted to use this models was training here on our own data. So they have a specific name here, XI Hackbeers and something else. And I did that actually. I can add a model, which is this one. This is here's the information I sent. It's the body. I send this information to the endpoint. I say I want to install this model. It's for object detection, and I put my API key in here. Just to change it later again. You can find your API key here in Roboflow. If you don't have one, you can create one. You can also see here how much usage you already had. You also need to pay for local usage. It's self-hosted images. And yes, so I use this API key and paste it in here, and then I can send this request to add my model to my local server. It will take some time. We actually could have also just called the model directly from our MetaQuest headset, but I like to just put it in here manually one time before, also to take care that everything is working correctly. And take some time. We got this feedback. We can also see again here in registered models. Yeah, we get back that this model is installed. It has a defined input high and read. And yeah, now we can work with this model locally by calling this endpoint. You don't need to know exactly how you call this model now, because that's all taken care of by our AI kit for Roboflow. And yes, this is our project. You can see we also have the camera rig here, Passthrough an environment raycaster to get the 3D position, the distance to an object. We have some input controller we was writing ourselves, which is basically just for the user interface. And we have our main part, it's the Roboflow caller script. Basically, what we need to just put in here is the IP address of your computer. You saw in Insomnia, I was putting here localhost, which is always addressing to your computer. But here it's really important to take care because where the application will run later is on the MetaQuest. So we want to call this computer from the MetaQuest. So we need to say exactly what is the local IP address of our computer where the server is running. And for Windows, it's by calling the opening the command line and calling this function ipconfig. And now I'm here in this router, and you can see this is my local IP address, .23. With that, I can always reach my laptop from any device in my local network. And yeah, the port stays 9001. And this is the Roboflow model I want to use, which is the Roboflow model we registered here. It's the same model. And that's also, we can set a lot of things here. The confidence, like it need to be at least 76% sure that it's correct to give us the feedback. We have the different classes we have here. If you don't have those figures available, totally understandable. You can also search on Roboflow for any other models. Just go into the Explore. And there's like we said, like 100 models available. You can, for example, search for models for searching bananas. Then you could just go into here. There's 3 models available. And you just copy this model ID and put it into the Roboflow toolkit. And you can also see here the different classes, overripe, ripe, and unripe, which you can then add here as a Roboflow classes so that you can identify them. And yes, this is just a prefab, like a round circle, which we put on top of our, on the position of our tracked element later. And the rest is just references to be seen. So what I first now will just do is I will build this project. You need to build this project for the MetaQuest as an APK for Android, because like we already mentioned at the earlier workshop, part is that you need to build an APK to be able to use the camera API. So that's what we will basically do now. Building it probably takes some time. Yes. Check the balance was scanned. And while I can already start sharing my screen of you using this cast functions. Okay, let's go running MetaQuest link. That is not necessary. Custom time and platform time. Okay, now you should be able to see what I see. So the application is still building. Maybe we are a bit unlucky with this building. Maybe I can share with you my view over here. So there's the spears already, and there's also Ricci already available for the upcoming hackathons we have in Barcelona and San Francisco. And they're still building. Actually, maybe I can search apps. Can we correct? It's um maybe it takes too much time right now. So maybe I will stop recasting first and let it build. Maybe at the end I can still show you that. So because yeah, there's one more thing we want to share with you. I'll just share it with you first and show how the application is working at the end. So there's one more thing we want to share with you. It's the AI workbench, and how there is video with you. Exactly. So it's a workbench we created to have all the different AI tools. It's having Google Gemini, Roboflow, just YOLO. You can take pictures from, you can track directly in these pictures. You can automatically convert between different formats, picture to image to text, text to image, even image to 3D models we have in here. It's really powerful and using all of the different providers you can see here. And it's available to you as a free to use kit also from us. You can just use it as a start point for your, I took it off here. You can use it as a start point for your project. And yeah, it's really, really powerful. Now, finally, the app was starting. I will show you one more time how our toolkit is working. I just need to start the casting one more time. Okay. Yes, you see the beard. I can make this gesture or like this, and you see the camera image here, and I can just click running Roboflow, and you see we can actually track the 3D position of these objects in real time for custom objects. Exactly. And that's how easy it is possible. I wanted to also jump into the code now, additional, but I guess we have more to show you, and it's quite simple. It's less than 200 lines of code to run this entire Roboflow thing for you, and you can just change it accordingly to whatever you want to build for custom AI model